Good morning, Algebra students. Today we're going to be covering the Unit 9 activity. So go ahead and open the activity and we'll get right to it. Okay. So let's go ahead and look at some of this stuff before. So it says introduction. During the summer, Joshua plans to work on his uncle's soybean farm. His uncle says that Joshua has two options for being paid. For the first option, Joshua earns $20 each day he works. For the second option, he earns 1 nickel for agreeing to work, and that amount doubles each day he works after that. Joshua plans on working 3 days a week for 8 weeks. Which option should he choose? Okay, so we're going to look at which option he should choose. So should he choose $20 a day? So $20 a day, $20 for the first day, $20 for the next day, $20 for the next day. Or should he choose starting with a nickel and then it doubles each day? So first day would be you get a nickel. Next day would be double that, so 10 cents. Then the next day would be double that, so 20 cents, and then so on. So which option should he choose? Well, let's look at basically the options. So option 1, the total earnings. So in the start, he earns nothing, but after the first day, he gets $20. 2 days, he gets $40. Oh wait, he gets $20 more each day. So on the second day, he gets $40. On the third day, he gets $60. So on the third day, he gets $60 for his day of work. On the fourth day, he gets $80 for that day of work. Okay, you can see by the 13th day, he's earning $260 a day. Not bad. But let's take a look at the other option. So the other option was he earns a nickel for starting, right? On the next day, 10 cents. Next day, 20 cents. Next day, 40 cents. So he worked a day of work and only got 40 cents here on the third day. And then that process goes on, you see? So doubling the amount he earns each day. But by the time you get to day 13, notice how much he earns on the last day, $409.60. So the tables show that while option 1 increases more rapidly at the beginning, after day 12, option 2 earns Joshua more money. Because Joshua plans to work 3 days each week for 8 weeks, which is greater than 12 days, he selects option 2. Okay. So we can represent Joshua's earnings from option 2 as an exponential relationship. And so this is our exponential relationship here. F of x equals a times b to the x. Now, what are a and b? A and b are just numbers. All right. Now, generally, A is the starting amount. So in the example we just did, the starting amount was 5 cents. So A would be 5 cents or 0.05. B is the growth rate. So in Joshua's example, the growth rate was 2 because it doubles each time. And this will make more sense as we go. Okay. So again, talking about that. And again, we're talking about A. A is the beginning amount. So in their case, in Joshua's case, the beginning amount, A is 5 cents, 0.05. The rate at which it grows is 2 because it doubles each time. And so the function for his growth is this, where x is the number of days. So if you want to figure out how much he earned on the 10th day, you would just replace x with 10 and then work out what that is. If you want to figure out how much he earned on the 13th day, you just replace x with 13, so on. Notice that each time it's times 2. So 0.05 times 2 gives you 10. 10 times 2 gives you 20, all the way down. Times 2 times 2 times 2. Now let's talk about exponential decay. So The one we covered in Joshua's case was called exponential growth. But exponential decay is very similar, where you have a starting amount, but notice the amount decreases over time. That's what we call exponential decay. So in this case, the starting amount is at time 0, 9. So A in this case is 9. And we're using essentially the same formula, that f of x equals a times b to the power of x. Now in this case, a is 9. The b in this case is 1/3, because notice it went from 9, but on the next step over it's 3, and then on the next step over it's 1. So really you go from 9 to 3 to 1, so you're dividing by 3 each time. 9 divided by 3 gives you 3, 3 divided by 3 gives you 1. So the common ratio in this case is 1/3. Or in other words, that's the b in the function. And you can see this function, again, f of x equals a times b to the power of x. Here it is written here as well, f of x equals a times b to the power of x. The a in this case is 9, and the b 1/3. All right, now we're going to talk more about this throughout this lesson. So let's go ahead and look. Whoop, it's breaking out a little bit. Okay. There we go. Okay. A media company wants to track the results of its new marketing plan. So the video production manager recorded the number of views for one of the company's online videos. The results of the first 5 weeks are shown in the table. So at the beginning, it had this many views, 5,120. After a week, it had this many views. After 2 weeks, 3 weeks, so on. You can see the number of views are going up as you go. All right, now write an equation to model the relationship between the number of weeks x and the number of views f of x. Enter the correct answer in the box by replacing the values of a and b. So essentially, we're replacing a and b in this case. Now, just like before, a is the starting amount. So in our case, the value for a is 5,120. And we could just replace that here. Now, b is whatever we're multiplying by each time. So what are we multiplying by each time as we go down here? So in other words, 5,120 times what would give me 6,400? Let me pull up a Jamboard for that. Have my Jamboard here. So one of the first amount was 5,120. Then 6,400 and 8,000. So let's just start with these values here. And we want to figure out, what are we multiplying by each time? So what are we multiplying by to go from here to here? What are we multiplying by to go from here to here? So in other words, 5,120 times what would give me this? 6,400. And 6,400 times what would give me 8,000. That's what we need to figure out. So I want you to take a moment, see if you can figure it out. Go and pause the video, see if you can figure out what that is. Okay. Well, hopefully you were able to get it, but if not, you could just divide one value divided by the other. So 6,400 divided by 5,120 will tell us. So with our calculator, 6,400 divided by 5,120, I got 1.25. Hopefully you got the same. So we're multiplying by 1.25. Is that the same here? Multiplying by 1.25? Well, let's check. 6,400 times 1.25. Let's see if that gives us 8,000. And it does, right? So we're multiplying by 1.25 each time. And again, to find that, you would just take the one term divided by this term, should give you that. Or this divided by this should give you that. It should be the same throughout. And that's one of the keys with an exponential growth or decay. It should be multiplied by the same amount each time. So in our case, that b is 1.25. Now, how can I tell it's exponential growth? Well, I can see from the numbers that it's growing, so I know it's exponential growth. But is there another way to tell that it's exponential growth? Well, yes. The b term, if the b is greater than 1, it's exponential growth. If the b is less than 1, say like 0.8, then it's exponential decay. So it all depends on the b value. If the b is greater than 1, it's growth. If the b is less than 1, it's decay. Let's take a look at the next one. During the same time, the digital print manager tracked the number of visits to the website's homepage. He found that before launching the new marketing plan, there were 4,800 visits. That's the starting amount. Over the course of the next 5 weeks, the number of site visits increased by a factor of 1.5 each week. Write an equation to model the relationship between the number of weeks x and the number of site visits f of x. Enter the correct answer in the box by replacing a and b. So it's similar to the one we just did, except they're not giving us values down the list. But replace a with the starting amount. What is the starting amount in this case? And replace b by the growth factor. So replace a and b, a with the starting amount and b with the growth factor based on this. All right, see if you can do that. All right. During the team meeting, both managers shared their findings. Complete the statement describing their combined results. Select the correct answer from each drop-down menu. The initial number of video views was the same as, more than, fewer than, the initial value of site visits. So what was greater, the number of video views or the site visits in the beginning? Well, the video views was 5,120. Site visits was this. So the initial number of video views was more than the initial number of site visits. And the number of views grew by a smaller factor, right? Because the video views grew by a factor of 1.25, whereas this one, the video factors grew by a factor of 1.5. So the video views grew by a smaller factor than the number of site visits. The difference between the total number of site visits and the video views after 5 weeks is, well, for that, I guess we're going to have to go over what this is. Starting amount and the growth factor. Okay, so hopefully you're able to get that. But let's figure out how much they were after 5 weeks. So after 5 weeks, we already know this one was 15,625. Let's figure out what this one is after 5 weeks. So our function is 4,800 times 1.5. And we're going to replace x with the number of weeks. So in this case, 5 weeks. And let's figure out what that is. Now, when we're calculating this, you want to do the exponent first. You do the exponent first before multiplying, just following the order of operations. Exponents before multiplying. So 1.5 to the power of 5 times 4,800, 36,450. So the number of site views was this, which is much larger than the number of video views in 5 weeks. So visiting the site was more. The difference between the total number of site visits and the video views 5 weeks is, so what's the difference between them? That means we have to subtract. So this amount, 36,450, minus what it was at 5 weeks here. So minus 15,625. So 20,825. And there we go. All right. So when asked for the difference between two things, you subtract them difference. Okay, question 2. An industrial company machine has the ability to reduce image dimensions by a certain percentage each time it copies. A design began with a length of 16 inches, represented by the point 0, 16. After going through the copy machine once, its length is 12, represented by the point 1, 12. Enter the correct answer in the box by replacing the values of A and B. So again, A is the starting amount. So hopefully you know what the starting amount is here. What was the starting amount for the design's length? Well, it's represented by this point 0, 16. And there you go. When you think of it as a coordinate point, the starting amount is always 0, something. It's the y-intercept. And the B represents the growth rate. Now, notice it went from 16 to 12. So it's actually going down. So that tells us it's going to be like an exponential decay. So we went from 16 to 12. So what are we multiplying by to go from 16 to 12? Well, again, to figure that out, you could always divide 12 divided by 16. 12 divided by 16, 0.75. So 0.75 is our growth rate. Well, it's actually not a growth rate because it's actually exponential decay. Remember how I know it's exponential decay? Well, first of all, the values are going down. I went from 16 to 12, so I know it's decaying, going down. But also, this value in here is less than 1, right? 0.75 is less than 1. So whenever you have a growth rate that is less than 1, it's actually a decay rate, okay? All right. Another copy machine has the ability to reduce image dimensions, but by a different percentage. This graph shows the results found when copying a design X times. Use the graph to write the equation modeling this relationship. So you can see our first point is 0, 8, and there's another point here, 1, 4. So it went from 8 to 4. And you can see there's like another point here. They didn't put a point here, but you can see 2, 2 here, right? So it went from 8 to 4 to 2, then to 1, then to 1/2. Enter the correct answer in the box by replacing the values of A and B. So what's the starting amount here? What's the starting amount here? See if you can figure that out. What's the starting amount here? What's the y-intercept, in other words? And what's the decay rate, right? It's decaying, right? It's going down. So it went from, excuse me. It went from 8 to 4. So it went from 8 to 4 to 2. So what's the decay rate here? Okay, see if you can figure that out. And replace A with the starting amount and B with whatever that decay rate was. Okay, both copy machines reduce the dimensions of images that are run through the machines. Which statement is true about the results using these copiers? Let's see, which one is true? As the number of copies increases, the dimensions of the images continue to increase. Well, is that what we see? As we go farther on the X, does our graph increase? Well, no. So that can't be right. As the number of copies increases, the dimensions of the images continue to increase. Again, as we go along the X, increase the number of copies. Is this increasing? No. As the number of copies increases, the dimensions of the images continue to decrease toward, but never reach, 0. I would say that sounds right. As you go along this, notice we're decreasing. So as X values go up, this graph is decreasing and it's approaching 0. You see how the graph is approaching the x-axis? It's approaching a dimension of 0. Right? You can imagine as they go down, 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 down. the size of it approaches 0. But it'll never actually touch 0. It'll never actually cross the x-axis. In other words, the x-axis is what we'll call an asymptote. And you'll go over that more in Algebra 2, as well as in pre-calculus, is some graphs have what's called an asymptote. That means the graph approaches it, but it doesn't cross that barrier. So in this case, this graph exponential decay graph like this has an asymptote that is the x-axis. So it approaches but never reaches 0. Let's take a look at the last one, just make sure. As the number of copies increases, the dimensions of the images continue to decrease until reaching 0. Well, no, because it won't actually reach 0. Okay, and that's it. I feel like that activity was not too bad. If it didn't make sense at some points, or you weren't able to figure out the parts that I asked you to do on your own, feel free to email me. You can email me at any time, and I'll get to answering your emails as soon as possible. And we could even schedule an appointment. I could see you by yourself and schedule an appointment one-on-one. So anyway, yeah, if that's your case, you still need extra help, feel free to email me. My email is ttrigg@ofy.org. That's trig with 2 G's at ofy.org. Okay, well, with that being said, I'll see you guys next time.